Okay, welcome to this video. I will quickly show you how we can identify oxidizing agents and reducing agents. First thing I want to go over is some definitions, and then I'm going to follow it with an example. So, oxidation is the loss of electrons, whereas reduction is the gain of electrons. The mnemonic for this is oil rig. Oh, I need a pen. Oil rig. So oxidation is loss and reduction is gain. So another thing you have to know is oxidation is accompanied with an increase in oxidation number. So say we have an atom that has an oxidation number of 0. And if we lost electrons, and electrons are negatively charged, so we lost, say, 2 electrons, we would have a positive 2 oxidation number at the end, because we pulled 2 negative electrons away from an atom, making it more positive because you lost negative charge. Now, you look at this, it says reduction is the gain of electrons. You may be thinking, what do you mean, reduction and gain? Those are 2 different things. Well, it will make more sense when you look at the oxidation numbers. So say we have an atom that has a positive 2 oxidation number. And if we gain 2 electrons on this atom, we would therefore have a 0 oxidation number at the end, because by gaining negative charge, you became less positive. That makes sense. So reduction is the gain of electrons, or to memorize it better, is that reduction is the decrease in oxidation number. So yeah, if you look at the next definition, which is the reducing agent, it says a species that reduces another molecule while itself is oxidized. You're thinking, wait, what? Well, basically what it's saying is it's a chemical species that is going to take electrons off of itself and dump it onto another molecule or another atom. It's going to take its own electrons and get rid of them. And therefore, it has lost electrons. So you can correlate a reducing agent with the molecule that was oxidized. Now, with oxidizing agent, you could then classify that as the one that was reduced. So it's kind of the opposite in a way. The reason why it's the opposite is they're using the word agent, and it's the thing that's doing it. So if you look at the next definition, oxidizing agent is a species that oxidizes another molecule while itself is reduced. So it is going to pull electrons off of another atom or another molecule, and by gaining electrons, you are therefore reduced. So the oxidizing agent is the atom or molecule that was reduced, and the reducing agent is the one that was oxidized. So let's do an example to make things more clear. All right, let's look at this example. We first must identify the oxidation numbers of each atom within each molecule. The first one up is cadmium. As you can see, it's by itself. It's neutral. It is only composed of other cadmium atoms, and by definition, it must have an oxidation number of 0. Now, if we look at this molecule, you can see that there's oxygen, there's nickel. Now, oxygen has an oxidation number of -2. It can have a different oxidation number in cases like hydrogen peroxide, because hydrogen has a +1. We have 2 hydrogens, so a total of +2, and therefore oxygen must each have a -1 to counter that +2. But in this example, in most examples, oxygen will have a oxidation number of -2. Now we have 2 oxygens, so we'll have a -4 total. So this nickel must have a +4 oxidation number. Let's look at this oxygen. This oxygen is in group 16, just like every other oxygen. Hydrogen has an oxidation number of +1 when it's grouped with other non-metals. We have 2 of them, so +1 plus another +1 would counter that, -2. But each hydrogen atom has a +1, just like each oxygen here has -2. Let's look at our products. We have cadmium, we have a hydroxide, oxygen has -2, +1, oxygen has a -2, but we have 2 of them, so we have a total of -4. We have 2 hydrogens. We have a total of +1, +1, +2, -2 total from this group. Therefore, our cadmium must have a +2 to counter that. So -2, +1. Let's look over here. Same thing. -2, +1. We have 2 of them, so -4. 2 of them, +2. -4 + 2 is -2. So this guy over here is +2. So let me remove some of this. +2. Now let's look at the changes in oxidation numbers. Our cadmium went from 0 to +2. So cadmium went from 0 to +2. We increased our oxidation number. By definition, that is oxidation. We lost electrons. So let's look at nickel. Nickel went from, where is nickel? +4 to +2. We decreased our oxidation number. Therefore, it has been reduced, or it's reduction. So cadmium was oxidized, nickel was reduced. And now we must identify our oxidizing agent and our reducing agent. So the shortcut I said before was just that they're opposites. So the atom that was reduced is the oxidizing agent, and the cadmium that gained oxidation number is the reducing agent. I hope this video helped. If you have any questions, just comment down below and I'll do my best to answer them.